Chapter 13, Correlation and Linear Regression, is talking about this idea of two variables, having data for those two variables, and then creating a relationship that exists between those variables. And by relationship, I mean if one variable is correlated with another, can we use the initial variable, what we call the independent variable, to predict the behavior of the dependent variable? And we're going to spell that out utilizing some graphs and other things today. When we think about correlation, it's important to know that we are not talking about causation necessarily. Those are two different things, correlation versus causation. A correlation just means that when one event happens, the other event also tends to happen. It's not necessarily saying that the first event is causing the second event. So we have to separate those two. Just because a rooster crows as the sun rises, those are correlated events every day. However, the rooster does not cause the sun to rise. So that's what we mean by there's a difference between correlation and causation. So you can see some of our learning objectives, explaining the purpose, calculate a correlation coefficient to test and interpret a relationship, apply regression analysis. So if we're talking about a correlation analysis, we're saying that we want to measure the relationship between two quantitative variables, right? That word quantitative is very important because we are talking about the ability for a variable to have, well, the need for the variable to have data associated with it in order for this to work out well. And that data should be, varying. The data should be something that changes. It doesn't have a standard deviation of 0, etc. The basic hypothesis of correlation analysis is that, or does the data indicate that there is a relationship between two quantitative variables? We looked at Applewood earlier in the semester, and if we wanted to plot that, it would look something like this, where we would say there is some relationship between the profit per vehicle and the age, but not a very strong one. And we'll look at how Excel is used for regression analysis a little bit later. Measuring the relationship, we have something called the R, the correlation of the coefficient of correlation right here. And what it does, it tells us the strength and the direction of the relationship between two variables, of the linear relationship between two interval or ratio scale variables. Very importantly as well, it goes from -1 to +1. -1 to +1. If you have an R, for example, of -0.5, we'd say there's a fairly strong negative relationship between two variables. +5, that's a positive relationship, fairly strong, not extremely strong, a little strong. And then if we have 0, we say that there is no relationship between the variables. So if I have a set of data, one is height for students in the class, the other is GPA, I'll probably get a 0 or close to 0 R, because we're not going to have much of a relationship between a student's height and their GPA. Whereas if I had students' GPA and say study hours per week, and I put that in Excel and crunch that data, there's a great chance we'll have a stronger relationship between study hours and GPA. So that's very important to know that we're going from -1, right, on our scale all the way to +1. Okay. A value near +1 indicates a direct or positive linear relationship between the variables, okay, meaning that they are very tightly correlated. Meaning if you say, as my income goes up, I buy more stuff. So the income consumption relationship is a very strong one. It may not be 1, but it's going to be close to 1 because you people tend to buy more stuff with higher income. And then a value near -1 indicates an inverse or negative linear relationship.
Well, the less you study, the lower your grade, they say.
Yeah, the thing with that one is that's actually positive because if you say less study, low grade, that means they're both going down in the same direction. A negative relationship has to be as one goes down, the other goes up, or as the other goes up, the other goes down. So the relationship would have to be as something increases, the other decreases.
So it would be something like the more TV you watch, the less grade you get, or the lesser the grade you get.
Okay. So if you, exactly. So if you have a variable of, independently watching TV, and then you correlate that, say, with GPA, that will be good because now we're talking about as one going up, the other tends to go down, and vice versa. As you decrease watching TV, GPA going up. And the relationship there is probably negative, but it's not probably going to be strong, meaning that, there's so many other factors. Like even if I stop watching TV altogether, I would still have to do other things to increase my GPA. Certainly that would help, but, I would need to actually study the material. I would need to be in a quiet place. So relationship is probably negative, but it's probably something like -0.1 or -0.05, as opposed to -0.8 or -0.9, where you can say, okay, there's some real correlations here. So that's important in terms of the strength part. So that's why I'm underscoring the need to understand strength versus direction. Watching less TV and a better GPA in terms of direction, probably negative. But in terms of strength, probably not very strong, which is different when we talk about income and consumption. The direction as income goes up and consumption going up is going to be positive, and the strength is going to be pretty strong. And that also would apply in the negative direction. As income goes down, the consumption is going to go down, which is still a positive relationship because as one goes down, the other one goes down, but the strength is going to be much stronger than the other example. So when we talk about R, we're talking about strength and direction. The correlation analysis, measuring relationship between two variables, also extends, well, we could extend that to a few examples here. And as we see them, and before I actually go to the bottom, let me show you what I was talking about earlier. That 0 means no correlation, the height and GPA story. And then we talked about that, and we talked about the positive relationship on the other side. So, like I said before, moderation around 0.5, not very strong, but not weak either. And then moderation on the positive side also of 0.5. So some examples at the bottom, income and number of children. The relationship, not very strong, right? We see no correlation. If we had a correlation, we would see more of a trend, either up or down. A price and quantity, one of our strongest theories in economics, the inverse or indirect relationship between price and quantity. So as one increases on the price side, right, the other one tends to decrease. People buy less stuff as the price goes up, and people buy more stuff as the price goes down. So that's what we call a negative correlation, right? And we can look at the word here, weak, right? Look at the word here, weak, because it's not perfectly linear. A perfectly linear relationship is our dots, right, on a straight line. Okay, if we go back to the previous slide, we can see the dots right here on the straight line. Okay, because this right here is as strong as it gets, meaning as the X increases, the Y decreases in the exact same way each time. That's about as strong as you can get of a relationship. And then we can also extend that logic to the positive side. Okay, so that's why we say that this is weak, because all the dots are not on the straight line. If they were, then we could say as price goes down by some amount, let's say 5 cents, quantity always goes up, or quantity purchased, the consumption of stuff, always goes up by the same amount. But because these are scattered all around the line, right, these dots here, right, it varies. As price goes down by a certain amount, then quantity will go up by other amounts, and it's not consistent. And that's why it's not a perfectly correlated weak relationship. Okay, it's probably going to be somewhere in this range here, as opposed to exactly at the -1. Strong positive correlation between hour studied and score. So we see here hour studied, and we see here score. So we're saying that as you increase your hours studied, right, there's a strong positive relationship. And we say it's stronger than price and quantity because the dots are closer to the straight line. Imagine that line I just put up there is straight. It's closer to the straight line than the dots on the price quantity graph. The closer the dots are to a line that is straight within the dots, then we say we have a stronger relationship, because we have hours being better able to predict the score. Okay, and all of that of what I just said is going to be very important when we get to regression analysis. It's just setting the stage for regression analysis. Any questions so far?
No.
Okay. All right, the R that I spoke of before, the R which can go from -1 all the way to +1, can be calculated as such. We see the formula right here, and we see that it's the summation of the difference, the multiplied difference between your X and your X bar and your Y minus Y bar. Okay, and we take that over n-1 times the standard deviation for X and the standard deviation for Y. All of these things at this point you can calculate very easily in Excel if you were to calculate the correlation coefficient by hand with a calculator. Okay, if we were to just, or even if you used Excel, if you just found, you know, the X bar first and the Y bar second, standard deviation, if you just found these individually in Excel, you can calculate it in Excel as well. But there's also a faster way. There's a function in Excel that we're going to get into momentarily. So here's our example. The sales manager of a copier company, Copier Sales of America, large sales force throughout the US and Canada, wants to determine whether there is a relationship between, look at this, number of sales calls made and the number of copiers sold that month. Now, just logically, you would think, yes, there's going to be a correlation between me calling people and me selling copiers. That's just basic logic. But the question is, how strong is that relationship? Everybody would likely say it's positive, but we want to also know the strength. And that's what the R gives us. It gives us direction and strength. So as per usual in statistics, you find a sample, right? And this person took a sample of 15 representatives, as we see right here, of calls made and how many copiers were sold in that particular month. So determine if the number of sales calls made and copiers sold are correlated. Okay, so if we ran this data, and actually let me switch over, I'm going to jump over to another screen here. In this example, it's telling us about copiers sold and whether or not, or sales calls made and whether or not copiers got sold. And so if you go to my website, you will see the data already ready to go. And if you open that up, you will see sales calls versus copiers sold in row format. And just personally, I like to work in column format. So I'm going to go ahead and transpose this. It's very simple in Excel. Just grab the data and hit Control C to copy it, and then go somewhere else, right click, Case Special, and then click on Transpose. And that will then create column-based data. So now I'm going to get rid of this. Same data, just in column formation. All right. And in the slide, let me pull the slide up here as well. In the slide, you already saw the outcome, right? The outcome was that there's a positive relationship. But the question is, how did they create what's known as a scatter plot? And here's the technique. You want to go to Insert, okay? You want to grab the data. You want to click on the charts area, right? And this is Insert Scatter. And then just click on that first one and it'll create the scatter plot for you. So now this chart looks just like what we have in the PowerPoint slide, which is right here. Okay, so I'm comfortable with that. There's plenty of things you can do with an Excel chart in terms of labeling. If you just really want to, just to show you more easily what's going on, if you want to put some axis titles, you just click right there on the chart elements. Okay, and then if you want to relabel that, you can see it's copier sold and sales calls made. So you have copier sold, copier sold, all right, as your Y. And then you have sales calls as your X. What Excel will do naturally, right, just in terms of the algorithm it already has, is it will take copier sold because it's on the right side, and it'll put it on the Y-axis. So whatever you have to the right of your data sets, right, if this were reversed, like it had sales calls over here in B, and sales calls would be on the Y-axis. So keep that in mind. If you want to maintain consistency, put your Y-axis data to the right when you're creating a scatter plot or really any graph. So here's my data, right? I'm comfortable with that. Any questions on how to create that scatter plot?
So the y-axis is the dependent.
Correct. Correct.
Okay.
That's your dependent variable, whereas sales calls is independent.
Okay.
And we're going to explore that once we finish up with the R. We'll get into the regression, the dependent versus independent variables. Okay. All right. Now, if we go back to the slides, we can see, right, we've created this chart right here. And the next slide is talking about how to interpret this information, because we've established the fact that we have some positive and it seems like relatively strong relationship, but whatever the rho is or whatever the R is, how do we interpret that R?